and Haru's AI Radio, bringing you today's show.
Thanks for tuning in. What's our theme today?
Today we're doing a deep dive into Chinese tech capability. EVs, AI, semiconductors. Where's the real deal and where are the limits?
Oh wow, quite the bold topic. Let's jump right in.
So let's start with the conclusion. Chinese tech is neither omnipotent nor fake. Each sector has real strengths mixed with genuine limitations.
I see. So we can't just say it's amazing or nothing special.
Exactly. Experts point out that media coverage about China tends to swing to extremes, especially in Japan.
Swing to extremes. What do you mean?
We alternate between China is a threat, and China's power is overrated, making balanced assessment really difficult.
Oh yeah, I definitely see both extreme opinions in the news.
That's why today, we're taking a calm look through the lens of technology, markets, and industrial structure.
Sounds good. Which sector are we starting with?
EVs first. As of 2024, China accounts for about 70% of global EV production.
70%. That's a massive number.
BYD sold 1.633 million vehicles in the first half of 2024, up 28% year over year. But here's the key point.
The key point.
55% of those sales were plug-in hybrid. For pure EVs, Tesla had 837,000, while BYD had effectively around 720,000.
So for pure EVs, Tesla's still ahead.
Right. But the real strength of Chinese EVs lies in battery technology. This is where it's genuinely the real deal.
Battery tech. What specifically makes it strong?
Especially LFP batteries, lithium iron phosphate. BYD and CATL dominate the global market with these.
What's different about LFP batteries compared to regular ones?
They do use nickel or cobalt, so raw material costs are about 30% lower. Plus, they have lower thermal runaway risk, making them safer.
Superior in both cost and safety. That's impressive.
From January to September 2024, these two companies accounted for 71.4% of automotive battery shipments in the Chinese market.
Over 70% with just two companies. That's total dominance.
And they've even overcome LFP's traditional weakness, energy density, which affects driving range per charge.
So they're overcoming the weaknesses?
Tech media reports say they're rapidly closing the gap with the older NMC battery.
Continuing to advance technically. Any specific products?
BYD's Blade battery is really something.
Blade battery?
It uses cell-to-pack technology to drastically reduce component count, giving advantages in both manufacturing cost and weight.
Wow, reducing component count cuts both cost and weight.
Actually, Tesla sources these Blade batteries from BYD.
Wait, Tesla buys from BYD?
Yep, that's solid proof. The technology is the real deal. Even competitors want to use it.
When rival companies buy your tech, you've got serious capability.
Foreign tech media analysis shows Chinese-made batteries are even found in some U.S. military supply chain.
Even the U.S. military. That's geopolitically huge.
Yeah, it's being recognized as a geopolitical risk. It shows they have capabilities that are hard to replace.
So battery tech is the real deal. But why can China produce so cheaply at such scale?
Great question. It's not just cheap labor. According to detailed JETRO analysis, BYD uses a vertical integration model.
Vertical integration model? What's that?
Batteries, motors, inverters, automotive chips. Everything is made in-house within the group. They don't buy externally.
So making everything themselves means no middleman markups.
Exactly. It drastically cuts parts procurement costs and inventory risk. ADF analysis says BYD can produce cheaper than EU manufacturers, even without subsidies.
Cheaper even without subsidies. That's genuine competitiveness.
Plus, there's economies of scale backed by the massive domestic market, millions of units annually.
The classic more you make, lower the per unit cost principle.
But here's the important part. Chinese apps have limitations too.
Limitations.
Production efficiency. Specialist media reports show in some processes. I take 600 seconds per vehicle versus Tesla's 40 seconds.
10 minutes versus 40 seconds. That's 15 times slower.
Right. Tesla is overwhelmingly ahead in automation and efficiency. Chinese EV strength is in volume and cost, not production efficiency yet.
So there are strong areas and weak areas.
Now let's talk about Made in China 25, a national strategy that was a turning point for Chinese tech.
Made in China? 2025. I've heard of it. What's the plan?
Announced in 2015, it set a goal of 70% self-sufficiency by 2025 in 10 sectors, including semiconductors, EVs, and robotics.
Pretty ambitious. How did it turn out?
According to Electronics Industry News Analysis, Phase 1 achieved decent results, especially in EVs and batteries, where progress exceeded targets.
Exceeded targets? That's impressive.
But entering the 20s, things changed. Escalating US-China tensions forced China to accelerate tech independence.
How did the escalation affect things?
Especially US semiconductor export controls from 2022 onward. Cutting off advanced chips paradoxically accelerated domestic production.
So being restricted forced them to make it themselves.
Exactly. From 2024 to 2025, the EU, US, and Canada sharply raised EV tariff.
How much did tariffs go up?
Up to 45%, was 100%. New barriers for Chinese EV overseas expansion.
100% means doubling the price. That's brutal.
But interestingly, Japan, Australia, and Thailand maintain 0% tariffs on Chinese EV. Responses are split.
Totally different by country. Japan doesn't charge tariffs.
Another important point, from 2026, the 15th five, EVs are expected to be removed from strategic emerging industry.
Wait, removed after putting so much effort in?
It's seen as a policy shift by President Xi. EVs have finished their development phase and are entering market-driven state.
Graduating from government support, stand on your own feet.
Right? Policy focus is shifting to basic research in semiconductors. Basic research funding allocation is projected to exceed 10%.
EVs matured enough, so now invest in other sectors.
Now let's talk AI. This is fascinating.
Chinese AI? DeepSeek was all over the news recently?
Yes! DeepSeek's emergence was shocking. DeepSeek for 3's training cost was about $5.60 million.
1,000. It can be done that cheaply?
And performance isn't bad either. Alibaba's Qwen 2.5 Max scored 89.4 on Arena Hard benchmark.
89.4? How does that compare to other models?
Claude 355 Sonnet is 85.2, higher than GPT-4o.
Higher than Claude? That's impressive.
Media analysis says the performance gap between Chinese LLMs and GPT-4, Claude, has narrowed to an average of 7 months.
7 months. They're catching up fast.
But we need to understand the difference between cutting-edge and practical specialization.
What's the difference?
Understanding AI analysis suggests Chinese models' strength lies in task-specific optimization, rather than cutting-edge generality.
Task-specific optimization?
The Qwen series specializes in Chinese language processing, coding, and mathematical reasoning for high scores. But it embodies lead multilingual support and cultural nuance.
So they compete in their strong suits.
Mixture of experts. Mo architecture cuts computational costs by about 70%.
70% reduction. That's how they make it cheap.
Achieving comparable performance cheaply is a typical Chinese tech approach.
Same strategy as EVs. Sufficient performance at low cost, not peak performance.
But recorded futures 2025 report says, while the US-China AI gap is narrowing, the US still leads in total computing resources, diverse training data access, and top talent depth.
What's the computing resource gap specifically?
NVIDIA's cutting-edge GPUs can't enter China due to US export control. That's a major constraint.
Can't get the hardware for computation.
Right. So China had to develop methods for efficient training with limited compute. DeepSeek's success is a result of that.
Constraints breed innovation.
Interestingly, there's cautious assessment from inside Chinese AI industry.
What do industry insiders think?
Alibaba's CTO said the probability of surpassing us, Google DeepMind or OpenAI in the next 3-5 years is less than 20%.
Less than 20%? They're saying that themselves?
He also said the compute gap is unbridgeable. That contrasts with some media claiming Chinese AI already surpassed the US.
The industry is analyzing itself soberly.
Meanwhile, OpenAI's Sam Altman warns the US is underestimating China's progress.
Perspectives differ by position.
DeepSeek's success showed efficient model. Development is possible under computing constraint. It questioned the US win by compute strategy.
So they proved you can compete with ingenuity, not just brute force.
Next is semiconductors. This is the most complex area with key points to understand.
Semiconductors are always in the news. What are the key points?
First, understand the distinction between advanced process and mature process. That's the key.
What's the difference between advanced and mature?
Advanced process is 7 nanometers or below. Microfabrication needed for smartphones and AI high-performance chip.
Smaller nanometers mean higher performance, right?
Right. But most global semiconductor demand is actually met by mature process. 28 nanometers and above.
Really? Advanced chips get all the attention though.
Automotive chips, industrial equipment, consumer electronics. Mature process is sufficient. And China is rapidly expanding market share here.
So can make everything, but don't need everything.
Exactly that. Expert network calls predict, by end of 2025, China will hold 28% of global mature node production capacity.
28%. That's pretty significant.
Nikkei reports those regulations affect advanced process, but impact on mature process is minimal.
Not evading regulations, but growing in sectors outside regulation scope.
Right. Now, advanced process. Heard about China's SMIC achieving 7 ENIAC without UV equipment?
Yes, used in Huawei phones, right?
Yeah, it's a real technical achievement, but looking closer reveals a lot.
Like what?
Smartphone info sites and Xenospectrum reports say they used inefficient UV multi-patterning.
Inefficient method?
Yield rate, good product rate, stays around 40%. TMC exceeds 90%, far superior.
40% versus 90%. Over half are defective?
Right. This raises cost by an estimated 50%. Technically feasible, but commercially tough.
Can make it, but too expensive to sell.
Exa Technologies analysis says SMIC will still be at 7 min-day in 2026, with 5 and 20% at under 20% yield.
Under 20% yield at 5 nm. Almost unusable.
The root issue is UV lithography equipment. Experts say 3 inten and below is extremely difficult without it.
Who makes UV equipment?
Dutch company ASML is the world's sole supplier, and US export controls stop supply to China.
Only one company. No alternative.
TrendForce reports China is developing domestic UV, but practical use isn't expected until early 2030s.
Early 2030s is still far off.
So China's strategy is shifting toward advances hard. So achieve self-sufficiency in mature and special purpose.
Compete where you can win. Same pattern as Eves and AI.
いつせるなすべて今日も俯瞰されました朝一では言う最新版本当のやつ X を開くその瞬間カチッと心に録音コントロール Z が許されるのはメアリーがいない今だけ関数は腐り F は関心もそして上司はビーマルが愚信者エクセル刑務所足すだ幸福可能シートの数増える服役年数今日もクラウドプロシーで夢をコピー貼り付けられた未来が怖いでも逃げられないそれがシャンネル用途列に挟まれてどこにもない価値を必死で演して金銭の中で生きてるふり今日も関数に詰まって辛抱ぜフィーボットテーブルごとをそしてマクロが暴れ出す
Now let's talk about national responses and supply chain complexity.
How are different countries responding?
Responses to Chinese tech rise vary significantly by country. For anti-tariffs, EU up to 45%.
100% tariff is basically a lockout.
Meanwhile, Japan, Australia, Thailand maintain 0%. The divergence is interesting.
Why the split?
Depends on each country's industrial structure and economic ties with China. Japan has a strong auto industry, may be confident they can compete.
Confidence in their own strength.
Look at semiconductor strategy. Export controls on advanced computing chips and manufacturing equipment aim to slow China's progress.
Slow, not stop.
Recorded future analysis says regulations slow rather than stop Chinese AI development.
Buying time.
But supply chain issues are more complex.
How complex?
China holds indispensable positions in critical materials like rare earths, gallium, germanium dye. Excluding China isn't realistic.
China controls the raw materials.
Meanwhile, China still depends on the West for UV equipment, advanced AI GPUs, semiconductor design software.
Mutual dependence.
Right. This interdependence is pushing tech competition towards selective decoupling rather than complete decoupling.
Selective decoupling means
Separate in sectors directly tied to national security, but maintain economically necessary sectors.
can't cut everything.
Let's look at government support. China rolled out fully purchased subsidies from 2010 to 2022.
Significant government investment.
Through the National Integrated Circuit Industry Investment Fund, over 6 trillion yen poured into semiconductors since 2014.
6 trillion yen. National level investment. .o.
Policy results: 17 Chinese companies ranked in global top 100 semiconductor sale.
17 companies made it in.
But subsidies bring short-term success, while potentially causing overcapacity, profit erosion, and shakeout.
Subsidy dependence leads to excessive competition, killing profitability.
The EV industry already shows this. Price wars constantly erode profit margins.
Growing but not profitable. Is that sustainable?
Let's look at future prospect. Some sectors will grow easily, others will plateau.
Start with the growth sector.
Mature process semiconductors projected to grow from $183 billion in 2024.
About 1.6 growth.
Practical AI applications in China market projected to grow from $34 over 4 wag.
4As. AI application growth is massive.
Cost-focused EV batteries like LFP, raw material cost and safety advantages expected to continue.
Strengths persist.
In automotive software and autonomous driving, Advantages possible from adapting to China's uniquely complex traffic environment.
Development tailored to Chinese road conditions?
Right. Lots of electric bikes, pedestrians, unique driving custom.
What about sectors hitting limits?
Advanced process semiconductors, 7 nm and below. Experts say 3 nm and below extremely difficult without UV access.
UV remains the bottleneck.
General purpose AI so tough. Gap with Western models in multilingual and multicultural support will persist.
Specialization strength is conversely a weakness.
Overseas EV markets tough. Tariff barriers constrain expansion in Western markets.
100% tariffs leave no options.
Cutting-edge AI research tough. Gaps in computing resources and top talent.
Can't buy NVIDIA GPS, huge constraint.
Structural challenges too. Real estate slump, local government debt, population decline. Labor force projected to drop 0.83% annually 2022 to 2035.
Population decline, same problem as Japan.
These structural issues can constrain long-term growth. Easy to overlook focusing only on tech sector.
No matter how hard tech companies try, they can't escape overall economic issues.
Battery companies face political resistance, setting up North American plant. Not just technical but political hurdles rising.
Technical capability means nothing if not accepted.
Chinese tech firms sometimes required to be party or government spokespeople, increasing risk of being caught in US-China friction.
It's not just business anymore.
Let's wrap up. To summarize today's discussion, Chinese tech is neither omnipotent nor fake.
Real strengths and limitations mixed across sectors.
Real strengths. First, LFP battery tech. Tesla buys it. Us military and AI firms depend on it.
Batteries are undeniably world-class.
Cost competitiveness via vertical integration. Cheaper than EU, even without subsidy.
Real competitiveness.
Mature process. Semiconductor self-sufficiency. Projected to hold 28% of global capacity.
Not cutting edge, but covers most demand.
Chinese coding specialized. AI models. Efficient training narrowed performance gap to 7 months.
World-class in their specialties.
Limitations. Advanced process. Semiconductor. 3 nm and below. Difficult without UV dye.
Bottleneck unresolved.
General purpose. AI. Gap persists in multilingual cultural adaptation.
Strong specialized, weak general.
F reduction efficiency body wild. Tesla 40 seconds versus BYD 600 seconds.
Volume capable but efficiency lagging.
Overseas market expansion. 100% tariff wall.
Technical capability but market access blocked.
Long-term sustainability without subsidy. Price war is eroding profit margin.
Unprofitable business isn't sustainable.
Bottom line, not China, amazing, or China underwhelming. But this sector is strong. That sector has limits, is the accurate view.
Important to assess calmly sector by sector by sector.
About what listeners, keep this mixed strengths and weaknesses mindset when consuming news. It'll help you judge information more accurately.
Don't jump to amazing or terrible from one article.
If today's discussion resonated, please share your thoughts in the comments. Would love to hear from you.
We might even reply directly, so please comment freely.
So today, we deep dive into assessing Chinese tech capability.
Really clarified that EVs, AI, and semiconductors each have strengths and weaknesses?
Tech news will keep coming, so hope you'll apply today's perspective going forward.
See you next time.
Bye-bye!
Bye-bye.